Hi, and welcome to part 2. In this one, we're going to see what the change in pH and how it affects enzyme activity. So basically, I think we should all know this by now, but just in case, I'm just putting it here. We have something called the pH scale, and that allows us to see how acidic or how basic a substance is. So the scale is that 1 is the most acidic, 7 is neutral, and 14 is basic. And what we're going to check today is that how does this scale, how does pH affect relative enzyme activity? Now to start off, I think I should make some things clear. We're checking the relative enzyme activity of pepsin. And as you can see in the hypothesis, I've said the enzyme pepsin will work more efficiently at an acidic pH. The equipment that we are going to use are 8 test tubes, acid, 1 boiled egg whites, incubator, 100 ml distilled water, and half a teaspoon of pepsin. Going on, here's my risk assessment. Well, obviously we are using acid, so that can be dangerous to the eyes, and in order to combat that, we can wear safety goggles. To add on, it can also be dangerous to our hands, and to counteract this, we can just wear safety gloves. Here's my method. Sorry for the messy writing, but I was kind of in a rush. So, number 1, we fill the test tube with 100 ml of distilled water. 2, we place it in half a teaspoon of pepsin inside test tube of distilled water. Add different amounts of acid and water to prepare 7 pepsin solutions inside the test tubes with a pH from 1 to 8. We can label these test tubes according to their pH. We prepare egg whites and to ensure accuracy, add the same amount of egg whites to every test tube. Okay, to continue, through observing the test tubes, place test tubes in order from least pepsin activity to most pepsin activity. Allocate each a relative activity and number from 1, most active, to 7, least active. So as you can see, our most active pH was at 5. And now this kind of makes sense if you think about it, because pH 5 is usually found in the stomach. So in this case, this does make sense because pepsin is also found in the stomach. 4. All these are under 7, which is neutral, and all these are acidic. They were the most effective. They're optimal. So these pHs were optimal for the enzyme. And now we can continue on to some more important information that we should know. In this test, our independent variable were the pH levels, because that is something that we changed. Always remember, independent. So, independent is something that we change, something that I change, something that I change. I was going to choose a pretty color. I change. So something that I change, right? Whereas dependent is what actually changes, or what is altered because of the independent variable. So in this case, we change our pH levels. We change them. We definitely change them. But because we change these pH levels, the dependent variable, which is the reactivity of pepsin on egg whites, changes also. So if I had my pH levels at a different level, then obviously the reactivity of pepsin would also change. So that's a dependent variable, something that changes because of something that we've already changed. Now inside this test, we also had a control. I didn't mention it at the top or in the method, it's just because of me being clumsy, but the control was actually 10 ml of distilled water with no added acid. Now, the only reason why you would have a control in this test is just to show the difference between how fast it actually, what the pHs actually do, and not just that, just to see that the pH is actually making a difference to whatever we're doing. Now, just to add on, lastly, we have the constant variables of temperature of the incubator, which means that we never changed these variables. These variables stayed the same throughout the entire experiment. We had the temperature of the incubator, size of egg whites, and amount of pepsin in each test tube. So, this is the graph that I've just come up with, and this is how it looks like. So, relative enzyme activity. Now, you can see that the activity was at its peak at around 4.5 to 7. So over here, that's the most enzyme activity, and that is because these these pH levels, 4, 5, and 6, right, are optimal for the enzyme. Okay, so as we can see, we've finished this last course, and that's basically all I had to show you today. I hope you enjoyed this, and I will be back for the next one. Thanks.